Ordinary white light is dispersed by a prism into a continuous spectrum. And I put the word continuous in quotes here because while the spectrum looks continuous to us, if, as Einstein suggested, light is in fact quantized, then if we really look at it, that spectrum isn't quite continuous. There are little jumps between one frequency and the next. Nonetheless, often in fact, it's just referred to as a continuous spectrum. From the gas in a nearly evacuated gas discharge tube, we instead get a line spectrum. What we see here are two spectra, the absorption spectrum of hydrogen and the emission spectrum of hydrogen. And you can see that there is clearly a correspondence here, where in one case we have dark lines with a colored background. In the other case we have a dark background with discrete colored lines. The difference here is that an absorption spectrum is if in this case hydrogen, is absorbing light from an external source. In other words, if the source of the light is behind the hydrogen and is traveling through the hydrogen before it gets to us as the observers. And what happens is hydrogen tends to absorb certain frequencies of light and none of the others. So the others make it through to our eyes. On the other hand, an emission spectrum is what we observe when the hydrogen, in this case, has been energized and is emitting light. So if we have some hydrogen gas and we energize it and it emits light, it tends to emit light of those particular frequencies and no other.